Cement performs several important functions in an oil well. It fills the annular space between the outside of the casing and the formation, and bonds the casing to the formation. This seals off the annular space around the casing, preventing hydrocarbons from flowing out of the formation and into the well. A cement job that properly seals the annular space around the casing is said to have achieved zonal isolation. The cementing process is procedurally and technically complex. This animation describes the basic procedure that BP and Halliburton plan to use to pump cement at the bottom of Macondo. With the production casing, float collar, and reamer shoe in place at the bottom of the well, the cementing crew prepares the wellbore by circulating drilling mud, shown here in brown, through the wellbore. This helps to condition the mud and remove any debris from the wellbore. The cementing crew pumps the mud down the production casing. The mud flows down the inside of the casing, through the float valves, out the reamer shoe, and back up the annular space outside the casing. The rig crew began the cementing process at Macondo by pumping a small volume of base oil down the well, shown here in purple. Then the crew pumped spacer fluid, shown here in orange. The spacer fluid is designed to help prevent the oil-based drilling mud from contaminating the water-based cement. Mud contamination can slow down the cement setting process or even prevent it altogether. Wiper plugs are another tool that cementers use to help prevent cement contamination. The wiper plugs mechanically separate the drilling mud and spacer fluid from the cement slurry. They have plastic ribs on the sides that wipe the sides of the production casing as they travel. This wiping action helps to remove mud residue from the production casing, further reducing cement contamination. You will see two wiper plugs in this animation. The first plug, drawn here in red, is the bottom plug. The bottom plug travels down to the bottom of the well, pushed down by the fluids above. When the bottom plug arrives at the bottom of the well, the float collar prevents it from moving further. The pressure behind the bottom plug bursts a membrane in the plug so that cement can flow through the plug and down through the float valves. The dark gray material shown here is cement slurry. The cement slurry flows through the ruptured bottom plug and down through the float valves. The light gray material shown here is nitrogen foam cement slurry. The Macondo cementing crew injected nitrogen into the middle section of the cement slurry in order to make the slurry lighter. This would reduce the pressure the cement exerted on the formation and help to prevent lost returns. When fluids flow out the reamer shoe, they turn the corner and begin flowing back up through the annular space. Here you see the base oil and spacer turning the corner. The dark gray material shown here is on-foam tail cement slurry. The Macondo cementing crew stopped injecting nitrogen into the cement slurry near the end of the cementing process so that the cement in the shoe track would not have any nitrogen bubbles in it. The lead cement and foam cement flowed out the reamer shoe and into the annular space around the production casing. They then flowed up the annular space, creating a cement seal across the hydrocarbon zone from 18,104 to 18,175 feet below sea level. Finally, the second wiper plug landed at the bottom of the well. The top wiper plug, shown here in yellow, served the same function as the red bottom plug. It helped to prevent drilling mud from contaminating the cement. Unlike the bottom plug, the top plug was not designed to rupture when it reached the float collar. Instead, it blocked further flow down the well and ended the cementing process. At the end of the cementing process, the Macondo well should have looked like this. The shoe track should have been filled with approximately 180 linear feet of cement. The annular space should have been filled with approximately 1,000 feet of cement. The Chief Counsel's team believes that hydrocarbons flowed up the production casing. This means that the cement in the annular space failed to isolate the hydrocarbon zone, and the cement in the shoe track failed to bar flow up the production casing.
Hey there. subscribe to my channel, and also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.